Let me illustrate that here with Boyle's law. And again, notice I started off with the combined gas law. If we look at our data in the problem, we have this initial volume and there is some initial pressure. And basically, that volume of air is placed, underwater. As you go down, go underwater, pressure increases. And then what happens here is that we get a new volume, and we want to know what the pressure is at that depth. And since they give us this little information, we can also calculate how deep the snorkeler is with this problem. Now notice that nothing is said about temperature in this example. Well, if that's the case, then the temperature is constant. And that's your typical Boyle's law kind of setup. Well, if the temperature is constant, that means T1 and T2 are the same. Long story short, you can cancel that out in the expression, and you're left with what we know is Boyle's law. Now I've identified the volumes and the pressure up top here. So let's just go ahead and rearrange this. All right, we want P2. So P2 here, what do we want to do? Well, we want to get rid of V2. All right, we want to move V2 onto this side. If it's something multiplied by V2, well, we divide by V2 to get rid of it. All right, we can't stop there. Whatever mathematical operation we do on one side of the equal sign, we have to do the same on the other side. So then what does this look like? Just rearrange it just a little bit, clean it up. Now if I look at my units here, right, I'm dividing by two separate volumes. Just want to make sure that the volumes are the same, and they are here. So now I'm really allowed just to plug and chug into the problem. And again, for the math here, you want to multiply these two values together and then divide by the 7.5 on your calculator. And just like in the combined gas example, since it's multiplication to division are the only two operations, you can do this in any order. And if I do the math, I get 2.1 atmosphere, which, kind of makes sense. The volume is basically cut in half. The pressure is doubling. That's how this works. Now, this last part of the problem, this guy here, how deep is the snorkel? Let's just go ahead and answer this real quick. So notice what the problem is giving us. This is actually a conversion factor. Right? It's saying that for every 10 meters that you drop in water, that's an additional 1 atmosphere of pressure being applied to the system. It's like 12 inches equals a foot, 100 centimeters in a meter. It's a conversion factor. Well, here I have one unit, and I want to go to how deep. That's in meters. I want to go from atmosphere to meters. Well, there we are, atmosphere to meters. And just like we learned in chapter 2, right, this is just a regular dimensional analysis type problem. Right? The unit that I want to cancel out, that portion is going to go on the bottom, and the other unit is going to go on top. So this is going to be 21 meters to generate this atmosphere, or this pressure, I should say. Now again, in these two problems that I've done so far, conditions have changed. And whenever you do see that, you use combined gas law or Charles's law or Boyle's law to do those calculations.